Okay, so we have, instead of a square root this time, we have a cubed root. And so one of the first things we want to do is get the cubed root isolated. Okay, so we're going to rewrite this as the cubed root of 3x minus 1 equals negative 4. Okay. So now I'm going to do the opposite. The opposite of a cubed root is cubing. So I'm going to take and I'm going to cube, and I'm going to cube, so I end up with 3x minus 1 equals negative 4 to the third power, which is negative 64. Because 4 times 4 times 4 is 64. Alright, so 3x is going to actually equal negative 63, and therefore x equals negative 21. Okay, so probably should run a check on it. You want to substitute back in, just to be on the safe side that it works. Right, so we're going to place, say, the cubed root of 3 times negative 21 minus 1 plus 4 equals 0. 3 times negative 21 was 63, if you'll recall, negative 63, and negative 63 minus 1 is 64. So the cubed root of negative 64 plus 4 equals 0. Okay. So the cubed root of 64 is 4, and the cubed root of negative 64 is negative 4. So I now have negative 4 plus 4 equals 0. So 0 equals 0. It works. So x is equal to negative 21. Okay. All right. Now in 6, we have the absolute value symbols. Okay. And the absolute value, if you'll recall, the absolute value can be means this value could have been negative 5 or positive 5, since the whole thing equals 5. So usually what we do is we break this into two equations, and we say 2x plus 3 equaled 5. 2x plus 3 also equals negative 5. Okay, and then we solve that equation. So 2x equals 2, x equals 1, 2x equals negative 8, so x equals negative 4. Okay. And then we go ahead and check it. The absolute value of 2 times 1 plus 3, does it equal 5? Well, 2 times 1 is 2, plus 3 is 5. Absolute value 5. Well, it is 5. So that works. Okay, with negative 4, we say the absolute value of 2 times negative 4 plus 3. That's negative 8 plus 3, which gives us negative 5. And the absolute value of negative 5 is 5. So we have a winner there. So x equals 1 and x equals negative 4 are both good answers. All right, solve for the specified variable. Okay. So we are wanting to isolate the variable r. Okay. So trying to get r by itself. It's a fraction format, so probably the best thing to do is go ahead and find the least common denominator. And the least common denominator for this would simply be r times r1 times r2. Okay. As these are r subs, not r to a power. Okay. This just means this is just a generic capital R. This is the first R. That's the second R. Okay, they're their names. Okay. All right, so when we multiply through, since we have R, all we're going to have left is R1 and R2. Okay, for this one, we're going to have R and R2. And then since R2 is there, we'll have R and R1. Okay, so now we're looking to get